Assalamu alaikum. My name is SK Abu Said. My ID last four digit is 1120. Today our presentation topic is threshold logic, bridging, boolean gates and neural computing. Here is our team members and presented to MD Mehdi Hassan sir, lecturer, Department of Computer Science and Engineering, Daffodil International University. Next slide. Here we see what is threshold logic. Threshold logic is a fundamental concept in digital electronics serving as a bridge between traditional Boolean gates and the computational models of neural networks. And its core, a threshold logic gate TLG produces an output based on whether the weighted sum of its inputs meets or exceeds a fixed threshold. Key components of threshold logic is inputs x1 weighted W and a threshold T. The history. The concept organized the seminal MC Collas-Pitts neuron model in 1943, laying the groundwork for artificial intelligence and neuromorphic computing. Here we see TLG versus conventional logic gates. Conventional logic gates means and or not gates, and otherwise threshold logic gates is different. Conventional logic gates fixed function limited to predefined boolean operation, low functional density and high gate count. Then threshold logic gates is function defined by adjustable weights and threshold, highly flexible, high logic density. A single threshold logic defines can replace many conventional gates. That's why threshold logic gates is more important. It's reduced gate count and achieves complex functional with fewer components. That's all of my presentation. My next team member Moriam Jahan will continue from here.
Assalamu alaikum. Myself Moriam Jahan, the last four digit of my ID 1126. Today I am going to represent two topics. First topic implementation of a three input majority gate. Thus this slide I explain a three input majority gate. The output of this gate becomes on when two or more inputs are on. In this example, all the weights are equal to on and the threshold value is 2. We calculate the sum of the input, and if the sum is greater than or equal to the threshold, the output becomes on. Otherwise, the output remains 0. The table shows different input combination and their corresponding output. And the second topic is implementation of that technique. This slide describe a different implementation technique of threshold logic gates. First, the transistor level or analog approach, where OS are implemented using analog components like MOSFETs and current summing is used. Second, neural network inspired circuits, which use devices such as memory stores to create a programmable and adaptive OS. Third, reconfigurable digital logic, where threshold logic gates are designed using HDL languages like Verilog and VHDL and implemented on FPGA and ASIC. Now I would like to invite my another team member for explaining another part of the slide.
Thank you. Now I will discuss about application and its impact. Threshold or threshold logic is not just a theory. It has real world uses, especially in new technology areas. In AI hardware acceleration, TLGS act as the core neuron model for advanced AI chip, improving speed and efficiency for machine learning. In digital signal processing, TLGS help build fast adders, multiplier, and other key unit needed for processing signal. In pattern recognition, their ability to classify data make the grade for makes them great for systems that handle image and speech. Overall impact, it's reduce design complexity, simplify connection, and process greatly increase processing speed across many fields. Now, hardware optimization advantages. The natural feature of threshold logic offer big benefit for making better and more efficient hardware. Reduced gate count, area and power saving and high speed. Reduced gate count, a single TLG can replace many traditional logic, making circuit simpler. Area and power saving, fewer part means smaller chip and lower power use, key for portable and green devices. With few stages in the logic path, TLG, TLGS, but TLGS cut down delay, making them perfect for high speed math and real time tasks. Thank you. Now I will call my next teammate.
Hello, good evening, everyone. My name is Nirav Shaharajan. The last four digit of my ID is 1532. First of all, I would like to thank my honorable teacher and my teammates to help me in this presentation. So, in this presentation of threshold logic, my topic is its advantages and disadvantages. While offering numerous benefits, threshold logic also presents certain challenges that needs to be addressed. So the advantages are high functional density, achieve achieving higher complex functions with fewer gates. Second one is more lower power and area footprint, which means more compact and energy efficient designs. Flexible program and programmable logic. Functions can be easily reconfigured. Faster operations. Reduced logic depth leads to higher speed. Now the disadvantages. Complex design process. Finding optimal weights there and thresholds can be computationally intensive. Noise sensitivity. Analog implementations are susceptible to noise affecting reliability. And the third one is harder to test and scale. Verification for very large TLG systems possess significant challenges. Next slide. Next point is conclusion and future outlook. Threshold logic represents a pivotal evolution in computing, effectively bridging the gap between traditional digital logic and emerging neural computing paradigms. Summary: a vital evolution connecting conventional digital logic with neural computing concepts. Future promise: the key technology for next generation high efficiency AI or ML accelerators and advanced novel hardware like memory stores. Memory stores. Final statement: TLG is crucial for the future of high speed, low power, and intelligent computation. Next slide. Thank you for the presentation. Now I would like to end my presentation.
Thank you, everybody.